All right, let's do it. I hope you guys are excited. I'm really excited to get into it too. Yeah, we're gonna get started with a quick overview of what we're gonna cover today. So if we can go to the next slide, please. Thank you. All right, we're gonna start with an R and RStudio introduction, sort of briefly the differences between them and why we might um, want to use this over the alternative ways of doing data analysis. We're going to go into talking about packages a little bit because packages are where the real power in R comes from. It comes from the external software that we can load into R to make the magic happen. Um, we're going to go over some basic syntax in R, data structures in R, and creating and using objects such as data frames, which are sort of rich spreadsheets that we normally use. It's basically R's representation of a spreadsheet. Um, we're also going to talk about how you use R data objects, in particular, how we're going to index them. Basically, indexing is just how do I access a particular elements that is maybe I just want one variable, or maybe I just want one row, or maybe if I want a set of rows and a set of columns. So indexing is really important in any programming language, especially for data science applications. And finally, we're gonna load in our data set and perform some analysis and visualizations on it. If we can go to the next slide, please. All right, so R is a free programming language for statistical computing. The question I often see getting asked is if I already know Python or similar software, why would I want to use R as well? There are a couple of reasons on why one would want to learn R in addition to Python. Um, One of them being that R has a large amount of packages for statistical analysis for plotting and visualizations. R can handle virtually any data format such as CSV, XLSX, or text files. And last but not least, a big one for me is that R makes replication easy. So when I say replication, I mean something along the lines of you have a set of files that you will go as far as download all the data, clean, process the data, run all the models, generate the visualizations, and generate the final products that you can send directly to somebody else. Um, but then again, there's really no reason not to learn both R and Python, right? So knowledge of any programming language will help you pick up the next one fairly easily. So even though Python has better flexibility and compiling speeds thanks to it being a general purpose language, R has the best libraries for statistical analysis when it comes to data exploration. Um, so to sum up, R and Python both can do about the same things, although one will probably end up being your go-to as defined by your day-to-day work. Your programming abilities and your ability to read documentation and coding will keep increasing across knowing more languages. So next slide, please. Okay, so we've been talking about R as a language for statistical computing, but what exactly is RStudio? RStudio is like a front end, or what is referred to in programming world as an IDE, or integrated development environment. What RStudio does is it makes your experience with R a lot easier than just working with base R, just like Jupyter Notebook is a front end for Python. Um, RStudio can do a lot of things. It can organize your code, your output, your plots in a nice way with a very nice interface. It can autocomplete your code, highlight the syntax of your code so you can distinguish between what a function is and what a variable is. And finally, RStudio can help you view data and objects in R. So think of it like this. R is a programming language that runs computations and do all the heavy lifting, while RStudio is a front end that provides an interface by adding many convenient features and tools, similar to, let's say, having access to a speedometer, rear view mirrors, or a navigation system makes your driving much easier. Using RStudio's interface makes using R much easier as well. So if we can go to the next slide. All right. To give us a little bit of context, I want to start off by briefly talking about our data set, which is the San Diego Police Stops data set, the same data set as our Workshop 1 last week. But instead of using Python, we're going to use R today to give you all the benefit of knowing the two most popular programming languages in data science nowadays. Um, Hopefully everybody had this dataset downloaded as a CSV file and put it in the same directory as the R script. Once you have it, perhaps you're going to be wondering how to load it up in RStudio. Of course, we're going to jump into it, cut it up, do a little bit more exploratory as we get into the data. For those of you that did not attend our Workshop 1 last week, just for a general overview, we're going to work with 47 variables, and there are around 356,000 observations. In a structured dataset or something like a tabular format, variables are considered as the columns and observations are going to be your rows. So now we also have some missing data. You can see that there are around 20% of our data is missing, but there are no duplicate rows. While this dataset might seem like a large dataset as far as numbers that we work with every day goes, this is actually a small or a medium-sized dataset that you may work with in an actual production environment. So 300,000 and 356,000 rows might seem like a lot, but with modern technology and tools nowadays, it's not really a big deal to pull in and work with such a data set, which is what we're going to be doing today. The key variables we're going to be working with today is PID and stop ID. PID is going to be the identifier for the person that was involved in a stop, and stop ID is the actual identifier for the stops itself. So stop ID is going to be our primary key that differentiate each instance from our data. All right, next slide, please. Okay, the data dictionary is not going to be something we're going to pull into RStudio. This is basically just your representation of the data set. So you can either have it up on one screen, look at it prior, and say like, okay, stop ID is the type of integer, and it's a unique identifier for each stop instance in our dataset. You can also look at raise, which is a string. So we're going to be expecting character values in this variable. Then we also have the description for that variable, which is the officer's perception of the race of the subject. So basically, data dictionary is really helpful, especially when the number of variables in our dataset range from hundreds to thousands of variables. And also, if you want to create a dataset and you want to pass it along to somebody else, you're going to want to create a data dictionary to provide clarity and context for that somebody who would have no idea what each variable is. All right, next slide, please. All right, so this is going to kick off the interactive portion of our workshop. Let's actually jump right into RStudio and figure out what's going on. I'm going to switch over to sharing my screen, and then we can jump to RStudio together. All right, can you guys see my screen clearly? Hang on one second. All right, cool. So once you load up the R script, this is basically how your screen's gonna look like. I want to switch back to the slides really quick to explain the user interface of RStudio. So basically, RStudio screen is gonna be split into 4 separate windows. Um, this section right here is gonna be your R script where it's gonna store the R code as you type it through. Um, this panel right here is called the console or the output panel, where the outputs of your command is going to be printed or returned to you down here. This panel is a data objects panel where it stores all of your created objects or any data set that you load into RStudio. And this final panel is going to be the files. Your plot's going to be here, any available package, and any instructions on how to use a function or a package will appear down here in this panel. All right, with that taken care of, let's switch back to the R scripts that we have. All right, so in R, anything that starts with the hash symbol is considered as a comment. So R will not consider anything on the same line with the hash symbol. Anything with the hash symbol will not be executed, and R will just disregard anything that's on the same line with the hash symbols. Um, and if you add 4 dashes on the line on the command line, it's gonna make that command line an index. It's gonna make the command line index so you can reference or go to that comment section later on if you want to quickly go to a specific section that you want to see. And you can also collapse that comment section if you don't want to display the entire code within that section. All right. So basically, at its basic level, R is just a glorified computer, right? It can perform any mathematical operations just as you would do on a normal calculator. Um, and in order to execute a command in R, you just need to simply select the line that you want to execute and click on the run button over here, or you can just simply press Control Enter to execute a command in R. So let's go ahead and execute the first line where we want to do an addition of 2 plus 2. Let's select that line and then click run or press Control Enter, and you can see the result of 2 plus 2 is printed to us here in the console panel. All right. Let's go ahead and execute the second line, which is the square root of 9. Control Enter on that line, and the result will be printed out to us, which is 3, down here in the console panel. And once you executed a comment, it's going to automatically go to the next comment for you. So let's go ahead and execute 2 to the power of 3. Control Enter on that command line. It's going to give you 8. And log base 10 of 100, which should give us 2 down here. All right. Sometimes you might want to save your operations or your results into an object so that you can maybe reference it later or use it for other tasks. And in R, the assignment symbol is the little funny arrow right here. And the shortcut for it is Alt and then the hyphen key. Or on Mac, I think it's Option and then the hyphen or the dash key. You can also use the equal sign as well, but the arrow is actually preferred because it's the official syntax written for R. All right, so let's go ahead and save the operation of 10 multiplied by 6 into an object named A. Select that line, press Control Enter, and as you can see over here in our global environment panel, you can see that the object that we just created, A, has the value 60 saved into it right here. And if you want to print out the result of this object, we can type print and then the object inside of the parentheses, Control Enter this line, and the result that's saved into that data object will be printed to us down here in the console panel. Or we can just simply type the name of the object, execute that line, and the result will also be printed out to us without having to type out print, which saves us a little more time. All right, so R is case sensitive. So an object named uppercase A is going to be different from an object named lowercase a. So let's say we want to save the result of 4 plus 6 into an uppercase A object, like we do so. As you can see over here, the name of our uppercase object will appear here with the new values 10 that we saved to it. So A, uppercase A, is different. If you print the result of uppercase A, it's going to get us 10. And if you print the result of lowercase a, it's going to get us 60. So R is case sensitive. So do notice that when you name your objects in R. You can also remove any unused objects that we want to use. So let's say the uppercase A object is redundant and you're not going to use it anytime in the future and you want to remove it from our environment. So you can just type RM and then the name of the object you want to remove inside the parentheses. So RM stands for remove. Pretty intuitive. Execute that line and you can see over here, uppercase A object is removed from our environment. All right, any questions so far? So let's see. RStudio looks quite a bit older than ends. Do I have the right version? Actually, the older version or the newer versions of RStudio do not make that much of a difference. So it's not really important if you have an older versions of R. All right, for Jose Luis, yes, the equal sign works just the same as the arrow sign, but the arrow sign is more preferred in R because that's the official syntax that R use. Okay, for Vinay, it says object A not found. When it says object A not found, it's because you haven't assigned the object A. You haven't assigned any values to object A, so that's why it says object A is not found. Joseph, no, spacing does not really matter in R. It's gonna automatically know that you have excess space, and it will know to disregard those spaces. So don't worry about that. All right, if we don't have any more questions, let's go ahead and go to the next point that I want to introduce, which is data classes. So basically, there are three main data classes that you have to know in R. The first data class is numeric, which includes integer and decimal as well. So by the name suggests, any value that is the numeric value is of type numeric class. So let's say here we want to assign a number 12.6 into an object called num. Let's execute that line, and we can see over here in our global environment, the num object that we just created has an assigned value of 12.6. The next data objects, the next most popular data object in R is character, which includes characters and strings. Let's say, for example, over here you want to assign a male character into an object named char. We have to put the character objects in R inside quotation mark in order for R to recognize it as a character object. So let's execute this line. We can see over here a string of male is assigned to a char object. As I mentioned, characters objects in R have to be put inside quotation marks. So if we just assign male to an object named char without having male put inside quotation mark, it's going to give us an error because R does not recognize this as a character object because male is not put inside quotation marks. All right. Last but not least is the logical data class, which are simply true and false values. There are only two possible values for this data type. All right. So if we can just execute this line, you're going to see that we are calling defining a true value, and we can define a false value, or we can just do T, capital T, or capital F for short for true and false. But do notice that we have to put all of the letters in true and false uppercase in order for R to recognize that this is logical object. If we just put everything lowercase, it's not going to recognize this, and it's going to treat R is going to treat any lowercase true or false as another object. All right. Any questions so far before I go ahead and start in our data structures in R? Let me pull up the questions and answer to see if there are any questions for us. Is binary allowed as a particle of logical? Sri Charan, I'm sorry if I mispronounced your name, but no, binary is not allowed as a logical object in R. R only understands true or false as its logical object. So 1 and 2 would not be considered as a logical object. All right, let's go ahead and go to the next section, which is data structures in R. There are three main data structures in R that we have to know in order to do data science using R. The first data object is vector, which is simply a row or a column of data, and each element of vector has to be of the same type, either numeric, or all of them has to be characters, or all of them have to be logical. So within a vector in R, all of the elements in the same vector have to be of the same data type. So let's go ahead and create a sample data object in R. Here, in order to create a list or a vector in R, we're going to use the function C and parentheses and the objects that we want to create inside this parentheses. The C stands for combine. And what we're doing over here is we are trying to create a vector of 10 values from 1 to 10. So let's go ahead and execute this line and see what R gives us. It's going to give us back a vector of 10 values from 1 to 10 for us. All right, how about if we want to create a vector of values from 1 to 100? Can we just type 100 numbers inside the the vector in order to create this vector. I mean, yeah, we can do that, but it's gonna be time consuming, right? Nobody's gonna sit there and type out 100 values from 1 to 100. So in R, we can do that by simplifying, by specifying the colon symbol. So basically what this does is we're telling R, hey, create a vector for me from 1 to 100, and it's going to create a vector of 100 values for us. So basically the colon symbol in R just means up to. All right, we can also create a vector of character data as well, not just numeric. Here we're creating a vector of days of the week and put these days of the week in quotation marks. Execute that line. We're going to see that it's going to return us the character values of days of the week for us. As I mentioned earlier, character objects in R have to be put inside quotation mark. Good question, Parky. I'm gonna go into that answer right away. So yeah, as I mentioned earlier, character data has to be put in quotes. So if you want to create a vector of character data without having the elements of the vector put inside of quotation marks, or we just understand that as an object. And if you execute this line, R is not gonna be happy because it doesn't find any object named Monday. So character objects have to be in quotation marks. We can also create a vector of logical values. So here I'm just gonna create some sample true, false data. We can also abbreviate false and true to just simply F and T, all uppercase. It's going to give us the same vector, but instead of having to write the entire word out, we can just use the initial F and T. All right, the next data structure that I want to cover is matrix. So basically, matrix is a combination of multiple columns and multiple rows of the same data types. So similar to vector, all of the elements inside the matrix have to be of the same data type. Either all of them have to be numeric, or all of them have to be character, and all of them have to be logical. If we have one column, a different data type, that's not considered a matrix anymore. And last but not least, the most important and the most popular data type, data structure in R is data frame, which is multiple columns and multiple rows of data where the columns in data frame can be of different types, but the elements in the same column have to be of the same data types. So let's say over here, for example, we have a data frame with 3 different columns. The first column can be of numeric, the second column can be logical, and the third column can be character. So different columns in a data frame can be of different types, but elements within the same column have to be of the same type. All right. With that taken care of, let's go ahead and do some indexing. So basically indexing is if you want to get a specific elements, either a rows or columns of data, or a combination of rows and columns of data. So first, let's talk about how indexing in vector works. Again, I'm gonna create a vector of character values and save it into the days object. To answer the question that we had before, why did the C function not return anything in the console? It is because we save the days of the week into a days object. So it's not going to save, it's not going to print us anything back into the console because we save it in object. But as you can see here, the name of the object is stored here in our global environment panel. If we want RStudio to return the values back to us, we have to call that object again. So if we can execute that line, days of the week object is going to be printed to us. All right, cool. So what do you guys think the following command return days of 1? If we can have some guesses in the chat, that would be great. All right, I see a lot of Mondays and some Tuesdays. So if you guessed it was Monday, then you're correct. Because in R, indexing starts at 1. So the first element of anything in R starts at 1 instead of 0 like Python. If it was Python, then days of 1 would return Tuesday. You're correct. But in R, the first element starts at 1 instead of 0. So days of 1 is going to give us back Monday. All right. In R, in order to select in order to exclude something, you can include the minus sign before the element that you want to exclude, the minus sign or the hyphen or the dash key. So let's say over here, if we want to execute this command, it's going to return us everything except for the first element, which is Monday, because why not? Monday is awful. So yeah, in R, basically, if you want to exclude anything, just put the minus sign before that element in order to exclude that element when you indexing something. Okay, this command is trying to get the element, the 10th element from our vector. If we want to execute that line, it's going to give us NA or not applicable, because our vector only has seven elements. And if we want to get back 10th element, it's going to give us error. Not error, but it's going to give us an NA because it's not existent. 10th element is not existent in our vector. And the non-existent value in R is NA, is called NA, which stands for not applicable. We can also return a series of elements if we want by putting the order of the element inside the C function. Over here, let's say we want to return the first, the third, and the fifth elements from our vector. We can put their order of index 1, 3, and 5 inside of the C function and returns, and it's going to return us the first, the fifth, and the third elements. All right, as I mentioned before, we can use the colon in R to indicate we want to select a number up to a specific number in R. So here, this comment, what it's doing is it's going to return elements, second to the fifth elements for us, which is Tuesdays to Friday. All right. Any other questions before we move on to the next section, which is functions? All right, cool. I think everybody's very good to go. So I'm just gonna go ahead and move right into functions. So basically, a function is basically how R does things. Without functions, R is just a pretty way of storing numbers and values. So basically, function is a box. Think of function like a box where you can fit it some inputs. It does something to that inputs, and it's going to give you an output. So functions in R is recognized as the following format: a function name followed by parentheses. So let's for example, let's create a vector of 100 values from 1 to 100, so we can perform some sample functions on this vector. All right, run that command. As you can see here, my values is now a vector that we save values from 1 to 100 into this object. And if we want to print out this value just to quickly check if the values are created correctly, and you can see 1 to 100 of values are created inside our vector here. All right, we can use a function to find the mean of a vector by utilizing the function mean, and then the object that we want this function to perform on. So we want to perform the mean on my values object. So we put that object inside of our parentheses and execute this line. It's going to give us back the mean of this entire vector. We can also find other statistics like mean of our vector by executing the mean function, max function, or by executing the sum of our vector by sum function. We can also find the standard deviation of our vector by the SD function. We want to return the class. We want to return the class data class of this vector by typing function class. We want to find the length of our vector by using function length. It's going to return us a length of 100. And if we can find the log of each element of our vector, it will print out the log of each element. All right. Cool. Any questions so far that we can answer that we have covered? I see Leonid ask, what if we wanted to take the natural log? Then is it ln? Actually, the log function in R is doing the natural log for you already. If we want to do something else, it should be log and then the base of the values. Yeah, you're welcome. I got a question from Vinay. Why does some values show in square brackets 30 in the output? Oh, yeah, that's a great question. So the square brackets that you see is actually the starting index of that value. So for example here, as you can see, 12 inside this bracket means that the first number of that line, the index of the first number of that line is 12. So this, the index of this number is 23. And as you can see, the last number, the index of the last number is this number, is 100. So these square brackets is just indicating the index of the first number starting on that line. Did that answer your question? You're welcome. Cool. All right. Let's get a little bit more advanced and utilize another function to create a vector of normally distributed data with a mean of 20 and a standard deviation of 5. Okay, before we do that, I want to quickly talk about this line right here real quick. This line is not very important. Basically, what it does is it set a specific seed so that your results are the same as my results. So it's just a replication type of thing, replication purposes. So let's go ahead and execute that line so that our results are the same. All right, now let's try to simulate some normally distributed data with a mean of 20 and standard deviation of 1 by utilizing the function rnorm. So rnorm, what the function rnorm does is it's going to simulate some normal distributed data for you. What you have to do is you have to pass in some arguments in order for it to know what parameters to take. So here it needs the n, the value for n, which is how many values, how many numbers you want to create. It needs the value for mean argument. So what is the mean of our distribution we want it to be, and it needs the value for standard deviation. So if we just go ahead and execute that line and print out the results from sample vals, we can see that we are created a vector of 100 values for us, which is normally distributed with a mean of 20 and standard deviation of 5. All right, let's utilize another function, which is hist, to plot this distribution of the simulated data that we just created. So what hist function takes is it's gonna simply text the name of the objects that you want to plot. So let's go ahead and execute this line. As you can see over here, your plot will display in this bottom right panel, and it displays for you the distribution of our simulated data. Okay, so in R, in order to need help with a function, let's say sometimes you forgot how a function works or what the syntax of a specific function is, you can type the question mark and the name of that function. So let's go ahead and execute that line. You can see over here, it will switch to the help tab, and it's going to display all the information and instruction on how to use a specific functions, what the syntax of this function is, and what arguments this function needs to be passed in order to perform this function. So as we can see here, hist, which stands for histogram, obviously, takes a lot of other arguments, not just simply the name of the objects that you want to plot. It also takes a main, which is the name of your plot. It also takes x limit, which y limit, which is the range of your x-axis and y-axis, x label, y label, how you want to rename the labels in your plots, and many more are the arguments that you can pass in. But if you don't want to pass in all of those arguments and just want to pass in just the name of the object, it's gonna use the default values for all the other arguments. So let's say over here we want to, let's go back to our plot. Our plot looks kind of boring and kind of bland. So if we want to color the bins a little bit differently, rename our x-axis, rename our y-axis, we can do that also by specifying the other arguments in these functions. Let's say, for example, we want to change the color of the bins by a light blue color. We want to rename the x label into values instead of sample vals that we had. And we also want to name the plot's histogram of simulated data instead of the default name that are used. We can execute this line, and it's gonna adjust the plots according to what arguments that we passed in to our functions. All right, let's do another function by plotting the scatter plot of our data to see how our data are scattered by using the plot functions. Similar to the hist, it takes the object as the first argument, and then you can pass in other parameters or arguments to customize how your plot looks like. So if we want to plot the scatter plot, it's going to give us the values, how our values are scattered. All right, any questions so far before we actually move on to moving our data set into the environment? Is everybody good to go? All right, let's okay, oh, hold on. All right, let's take a 2 minutes break and I'm gonna open the flow of our session for questions, for any available questions for us. All right, I see some questions popping up. Does the help function show us the possible colors for the plot arguments? No, it actually does not. It's only gonna show you um, what type of arguments or values you can put in. It's not gonna tell you what kind of available colors you have. You have to look into the documentation of that specific function in order to know what kind of colors are available out there. Vinay, can we use bar plotting in this case? Yes, you can use bar plot, absolutely. But it's not gonna plot the things that you want. It's gonna look pretty weird. All right, if there are no any other questions, I will move on to bringing our data set into the environment by using the function read.csv and the name of our data set inside of this function in quotation marks. So let's go ahead and execute that line. So here are the functions that I always perform whenever I load in a new data set. I want to see the names of our data set, the names of the columns in this data set. I want to see the dimension of this data set. So the first number returned by the dim function, dimension, is going to be the rows, the number of the rows in our data set, and the second number is the how many columns are available in this data set. We can also take a look at the structure, the general structure of this data set by the str function. So this function is going to give us what type of data class is each column within our data set. So we can take a look, like a quick glance of the data classes of each column in our data set. We can print the first rows from our data set by using the head function. By default, this head function prints 6 row from our data set, but if you don't want the default 6 row, add the desired value as a second argument in this head function. So if, let's say, for example, if you want to print out the first 10 rows, you can add 10 as a second argument in the head function. If you want to look at the tail of the function of the data set instead, you can use a tail function instead of the head function. All right, we talked about indexing in vectors. Now let's talk about indexing in data frame. In R, data frame objects are indexed by specifying the row, by specifying the first arguments as rows and the second arguments as columns inside a square brackets. So for example, I want to get the result. I want to get back the value of the first row in the second column. I can put the index of the row, which is the first row, which is 1 in the first argument, and then the second column, which is 2, inside of the parentheses, inside of the square brackets of this data frame. So let's say we execute that line. Now, if we want to go to our data set, we can see that this first row of the second column should be 2018 July 1st. As you can see here, 2018 July 1st. All right, what do you guys think this command return? If we can get some guesses in the chat. I can see that some of you are not able to open the file. If you're not able to open the file, I think it's because you did not put you did not put the data set within the same directory as your script. So try doing that and see if you can open the data set. If you guess that it's gonna get us rows 1 to 5 of column 2 to 4, then you're correct. Yes, it's gonna return us rows 1 up to 5 of column 2 to 4. All right, and so in R, a blank in either of the rows or columns argument indicates that we want to select everything in that dimension. So for example, over here, if we leave the blank, if we leave the rows argument blank, we're telling R that I want to select all the rows of this data set, but only from column 1 to 3. So if we return that, we can see that R is trying to give us all the rows in our data set from column 1 to 3, only 3 columns, but because 356,000 of rows are so many, R just decides to display like 300 of them and just omitted the rest. All right, similarly, if we want to select only rows from 1 up to 3, but all of the columns, we can leave the columns argument blank. R is gonna know that we want to select all of the rows, all of the columns, but only from row 1 to 3. All right, we can also index a column by its position in the data frame. Let's say, for example, we want to return row 1 to 5 in column 4. We can do that by executing this line, specifying that I want to get back rows 1 to 5 of column 4 only, and it's going to return you the 5 values of column number 4. But if you don't know the position of the column or the variable, but you know the name of that variable, you can also specify the name of that variable inside the quotation mark as the columns argument. So let's say if we know that the name of the variable we want to return is stop duration, we can pass the name of the column in as well. Or the third way is we can also refer to the values in our variable with a $sign. So let's say we want to return values from 1 to 5 of column stop duration. We can do that by specifying the $sign and then the name of the variable and then the rows. So basically, these three do the same thing. It's just different of preference in how you want to index your data. We can also return elements that meet different conditions. So for example, I want to get back the rows that have stop duration higher than 60 minutes and only return the column date stop of these rows. I can do that as well. Or we can also chain conditions together. So over here, I want to return the rows that have stop duration longer than 60 minutes and the day stop is equal to December 25th of 2018 and only return the column reason for stop. I can also do that as well. All right, any questions so far before we move on to the next section, which is exploratory data analysis? Are we all good to go? All right, cool. So basically, exploratory to data analysis, EDA for short, is an approach for data analysis which employs a variety of visual representations to maximize the insight from a data set or uncover the underlying structure and extract important variables, detect outliers, and test the underlying assumptions. And one of the most important data analysis is data cleaning, which is the process of preparing our data for analysis by removing or modifying the data that's incorrect, incomplete, or irrelevant, or a duplicate, or improperly formatted. And missing values is one of the first steps that we have to do for the data cleaning process. And so there are many ways to deal with missing values. Most of them are beyond the scope of this course, since we are dealing a lot with text data in our data set. But in this case, we're just going to drop the columns from our data set that have a majority of missing values. So if you simply open your data frame over here, you can see that um, the missing data in R is just going to be treated as empty, as missing, as an empty string. So R does not recognize that as a really missing value. So what we have to do is we have to define, or we have to declare that these empty cells right here, these empty strings, are missing values by replacing the missing strings, the empty cells, by NA. So if we execute that line, go back to our data set, we can see that all of the missing cells, the empty cells, the missing keys, missing values are now considered as NA instead of just empty strings. And it's better that way because we can tell R, hey, these missing cells are actually missing values, not just empty. All right, this line right here is not very important, but by default, R uses scientific notation as a way to display a number with many decimal points. So let's say, for example, if we have a number like 0.0009, it's going to be displayed as 9.1234, 10 to the negative 5. So it's kind of counterintuitive. So I turn off, this line is just used to turn off a scientific notation so that we can look at the numbers as decimal points instead of scientific notations. All right, what we have to do first in dealing with missing data is we have to count the missing values in each columns of our data set, then calculate the portion of these missing values, and then convert it to percentage. All right, so if we can execute this line, just a quick check over here. What do you guys think? This, when we execute this line, it doesn't print anything back to us in the console? Yes, thank you, Leonid. Yes, because we stored it as an object. We stored the result of this operation in this object called missing amounts. So even when we execute this line, it doesn't print anything back to us because it's an object. It's an object stored within our environment. So if we want to get some results back, we can print that object once again in order to get some results back. All right. Wait, I haven't turned off my scientific notation. Yeah. Okay, let's run it again. How do you view the data file? If you were able to load in the data into our environment, you can just simply click on your dataset object over here in order to view your data. All right. Here is the percentage of missing. Here's the percentage of missing values in each column or each variable within our dataset. It's kind of confusing and it's kind of not very clear what we're looking at because the percentage are all over the place and it's not in a specific order for us to easily recognize what variable has the high percentage of missing values. So what we can do is we can sort it in, we can sort this object in a descending order. So we can print out, so we can see that landmark has the highest percentage of missing values by 99.987%, And school name, highway, exit, consented also has a very high percentage of missing values, 98, 97%, which is not very helpful to us if there are a lot of missing values. As a rule of thumb, variables that have more than 30% missing values should be dropped because we're not going to get much information out of such variables. So now that we save the percentage of missing values of each variable inside an object called missing amounts, we can do a bar plot of this object and see the number of percentage of missing values within each column. And if we just execute that line using the bar plot function, built-in function by R, it's gonna give us a bar plot that looks like this, which is not very aesthetics and not very beautiful. We can do a lot better than that. So in order to spice things up a little bit, we can use the ggplot2 package, which is the premier package for graphing in R. So first of all, let's install the package by executing this line. Install.packages ggplot2, the name of the package inside of quotation marks. And once we're done installing the package, in order to use the functions of the package have to be loaded into RStudio environment before we can access using its functions. So we can do that by typing library, the name of the package inside the parentheses, by loading that package into our environment. So let's go ahead and execute that. And here, I'm gonna replicate the same bar plot that we did with using the bar plot function, the R built-in function for bar plot. But instead, this time I'm gonna use the functions provided by ggplot2. The double quotation marks or the single quotation mark doesn't make a difference. They're the same thing, so you can use either of them is fine, Isabel. All right, cool. So if we execute this command, as we can see, that this bar plot is it looks much better than the previous bar plot that we used from the R built-in function. Oops. Where's the, yeah, here. It looks a lot cleaner, more beautiful looking, and it's neat. It's more neat than the built-in function by R. We can see that we have the color of the bins blue. We have a cutoff point. We have a cutoff point as a dash point in here of 30% more missing values. So any variables that have the bar plots higher than this 30% of missing values, we know that those variables are the ones we're going to get rid of. We have the variables names. We cover all of the variables name. We have X labels, Y label, and the title of our plots instead of the bar plot from using the built-in function from R. So basically, this function does the same thing, but it does a much better job of customizing and making your plots more clean. All right, so now that we know what kind of variables, what variables have higher than 30% of missing values, we save those variable names inside an object, and we can inside an object called missing values, and we can drop the variables that have more than 30% of missing values by running this command, and save the reduced variables inside a data frame object called df reduced. So basically what it's doing here is basically I want to select all the rows from my original data frame, but not the rows, but not the names of the rows that we want to drop by using the exclamation mark symbol, which is the negation operator in R. All right, duplicate columns, we're gonna take care of duplicate columns as well. So basically duplicate columns are redundant and they add unnecessary information to our data set. So taking a quick look at our data set, we can see that there are gender number 2, and there are perceived gender. So we have a feeling that these variables are kind of similar to each other. So why don't we take a look at the frequency of each elements within each columns, and we can do that by using table function, and then the columns that we want to count. So let's execute the first gender column. We can see that these are the counts for each elements within this column. Let's count the next. Let's count the frequency of the next variable, which is gender 2, and then the last variable, which is perceived gender. We can see here the counts, the frequency of each element within each column are basically similar to each other. So it's pretty obvious that gender 2, and perceived gender are just two representations of the same data. So let's drop 2 of them. So in this case, I just dropped gender 2 and perceived gender. So just like before, I'm selecting all the rows, but not the columns within this vector. All right, save that into our data set. And now also let's take a look at gender NC and gender nonconforming. By their naming, we can tell that these two variables are similar to each other. So in order to be on the safe side, let's double check and count the frequency of the elements within each columns. And we can see that these two variables have the exact same count of their frequency of the elements. So let's drop one of them, and in this case I drop the gender NC and keep the gender non-conforming variable. Okay, so next let's talk about the constant and low variance columns. A constant variable is the one that's not expected to change, and these variables do not contribute any information to our analysis. So let's take a look at some of them. By counting the number of unique values within each column, as we can see here, ORI and agency have just one unique values across all of the data set. So if we take a look at our data set real quick, because we're dealing with our San Diego data, so this makes sense, right? Agency, every value of agency is San Diego. Is San Diego. So because we're dealing with San Diego data, so that makes sense. And similar to constant variables, low variance columns imply that most values in such variables are close to equal. And while the values in these variables are not constant, they are close to each other, that they also do not give any useful information. So let's drop all of these constant variables and close to constant variables as well. So looking from this table, we can see the ORI, agency, stop in response to CFS, and up to perceived GBT, LGBT are all constant and low constant variables because they have a very low number of unique values. So let's drop all of these constant and low variance variables. All right, now we got a data set of only 26 variables left, which is a lot more usable to work with. So now that our data set is more easy to work with, let's take a look at some visualizations to see if we can identify some areas worth exploring. And so because race is our prominent categorical variable, before we visualize this variable, let's get a general idea of the distributions of stops by race. We can save our results in a data frame for later reference. So first, let's count all of the number of frequency of stops in our data set and group by race. If we execute that line, we can see that a new data frame is created over here, or a table, and the frequencies of stops for each race is displayed over here. And the naming convention is quite not very helpful, so let's rename the columns by race and then stops. By executing this line, as you can see, the name of the table is updated. So now that we have the stops, the frequency of stops for each race, we can add a percentage column representing the stops by executing this. And then the next line is to round to the 2 decimal points. So all of the frequency of these stops are converted to percentage now. All right. Let's sort the percentage columns in a descending order so that we can easily see the difference. So yeah, if we just execute this line, then the table will be sorted based on the descending order of percentage of stops. Now that we have a more usable table, we can use ggplot2 again to plot this finding. And as you can see here, white people accounts for 42% of all the stops in San Diego. Hispanic or Latino accounts for almost 29%. Black or African American, almost 20% of all the stops, and Native American accounts for the least amount of stops in San Diego with only 0.2% of all the stops. All right. Feature engineering. Feature engineering is basically the manipulation or transformation of our data into a more usable features. It's often used in machine learning to give models more practical variables to train with the goal of increasing accuracy. So let's take a look at the distribution of the stop duration in our data set by executing this line right here. We can see that the distribution of stop duration is heavily skewed and heavily right skewed to be specific. And in data science, most statistical analysis assume that our data is normally distributed in order to give a significant test results. And because the distribution of stop duration is so heavily right skewed, we can perform some transformation on this variable to make it more normally distributed and less skewed. And the type of transformation we can perform on our distribution really depends on the shape of skewness of the variable. And I put a link to a helpful resource over here. So if you want to learn more about transformation, you can click on that. But basically, for a right skew shape of type of distribution, a log transformation to that data is the best way to make it more normally distributed. So let's apply the log transformation to our data, to our variable, which is the stop duration. So execute that line, and then if we execute this line, we can see that the log transformation of stop duration is now more normally distributed compared to how it was originally. All right. Last but not least is the box plot, which allows us to see minimum values, median, maximum, and quartiles, and the concentration of outliers in our continuous or numerical variables. And let's execute this line and see the box plot distribution of the stop duration between different race in our data set. As you can see here, let me drag this out a little bit so it doesn't overlap. As you can see here, Black and African American and Hispanic has the highest median stop duration out of all the race, and Asian and South Asian people have the shortest amount of stop duration within all the races. All right, and that marks the end of our session. In order to wrap up, we can see that there are 2 points to take away, 2 key points to take away from this analysis. From San Diego consensus data, Black and African American only account for 6.5% of San Diego population, but they account for 20% of all the stops, the police stops in San Diego. So I pulled the data from San Diego consensus and put it in a table for us. And I also put our finding previously into the same table. So if we can execute these 3 lines together, we can see this new table that I created. And if we plot this table, we can see that all the other races are the stops distribution and the race distribution of other races are proportional to each other, except for African American, where there's a discrepancy between the race distribution. They only account for 6.5% of the population in San Diego, but they account for almost 20% in all of the police stops. And the second key points to take away is stops involving Native American and Black African American are the longest, and Asians have the shortest duration of all the stops in San Diego. So if we execute this line, we can see a table that display the stop duration, the mean of stop duration of all the races, and Asians and South Asians have the least amount of duration, and Blacks and Native American has the highest amount of stops duration. Yep, that's true, Martin. Pacific Islanders are stopped more often as well. All right, and here are some helpful resources that I really want to mention before we pass off our session to questions. The first resource is R for data science, which is freely available here at this link. This book is a very introductory and basic book to R in RStudio. It's going to help you learn data science very fluently and very fast. And this book is extremely suitable for beginners with no really programming experience and no data science experience as a whole. And the second book I really want to recommend is Applied Predictive Modeling by Max Kuhn. This book is a little more advanced, so I definitely recommend finishing the first book before going through this one. This book goes a little more in depth about predictive modeling process and data processing, data splitting, and the foundations of model tuning. So it's a little more advanced than the first book. So yeah, and that's the end of our workshop number 2. And here are the 2 questions assignments that you can do in order to get your certificates. And I'm gonna stop the presentation here and open the flow for any questions that you might have. Can you tell us about working with JSON file data in R? About converting and loading different. Yes, so basically R can pretty much work with any types of data data, right? It can also load in JSON data as well. Is the format of the data is gonna be the same, but instead of read.csv, we're gonna do something like a read.json and then pass your JSON file inside of it. And if you want to work with JSON file as is, you can, but it's more preferred to eventually convert the JSON file type to like a more tabular um, file in order to do data analysis anyways. So yeah, you can also work with JSON file in R just as well. All right, any other questions? What percentage of the homework? Okay, so in order to receive the course certificate, you have to finish the homework for all the three workshops. And the deadline for the homework is 1 week after workshop number 3, so you still have plenty of time. So don't worry about that. Thank you, Isabel. Thank you, Vivian. Thank you, Mafe. You're welcome. All right, I think I have one last question over here. Thank you. Thank you, Mara. Thank you, Tom. Thank you, Ikena.
Thank you so much, everyone.
Very good.
Thanks
Thank
for
you very
coming.
much. That was fantastic session. Hopefully, I enjoyed the session. I'm not sure about you. Hopefully, you enjoyed the session. If you enjoyed the session, make sure that you attend our poll. Give us feedback. We are a quick learner. Trust us. Give us some feedback. What you have been enjoying from these sessions. What we can do better in the future. What we can do that you succeed, and how we can return better to the community. That's our goal. And again, if you are very good with the coding, with the problem solving, with the statistics and probability, analytics is the great field, is the awesome career, is a very impactful with the bright future. We strongly recommend you to join the community. Also, a couple of things that I would like to mention. Make sure that for the next week, you do your prerequisite and be prepared and homework before attending the Tableau session. We will provide extra information and also all the manuals that maybe you need to apply or use before attending the workshop number 3. Also, like I said, I would like to thank our team. Uh, no doubt they did a fantastic job before preparing these code, analyze the data, presentation, many hours, many nights spent until the material, the content be ready. And I cannot be more proud of current situation from my colleagues. They are awesome. They are very uh, info, educated and experienced. And again, if you need any extra help, any extra question, don't hesitate to reach out through the community. We get back to you. We always one email away. And again, I would like to thank San Diego Tech Hub for providing such a great infrastructure and also a platform that we can connect with you guys. And we definitely look forward to the future sessions that we can contribute with the variety of the topics in data science. One more time, I would like to thank you for joining this session, allocating your time. Hopefully that has been productive Saturday for you guys. I know starting weekend with data science, coding in R cannot be that much fun, but hopefully you enjoy and learning here. Please stay in touch. Feel free to connect with us through other platforms such as LinkedIn, with the instructors, with me. We love to be in contact with all of you guys. And if you have any feedbacks, just let us know. So Anne, Erin, Matthew, Dylan, any last words you guys going to?
I think there's a few questions that are still open. I don't know if we're answering those before we.
Yeah, we're working through
Yeah.
those.
Okay.
I'll try to clear up everything before we close down the session. So I got a question from Igor. How do you debug your data manipulations and feature engineering? How do we make sure the answers are correct and we did not make an error in skill transformations? So Igor, you can always perform data manipulations and feature engineering on a smaller subset of data or even on a simulated example data to make sure that the feature engineering is doing the correct thing that it's supposed to do. You can always test on some sample data before you actually apply it on the actual data to make sure that it's doing the correct thing before applying the transformation on the actual real data. I have been trying to plot something like this. Omar. Okay, I think that take care of all the questions. If you guys have any other questions, you can always post it into. You can always post it in our community website under the workshop resources or the assignments topics. We can always answer your questions privately if you need further assistance.
Yeah.
Yep.
And then I just closed out Athena's question answering that. Your save dialogue option was grayed out. If you haven't changed anything, then you probably won't be able to save. You may not have changed anything in the session, so feel free to close, and then you should just be able to go back and open it up. And then Sri, is there any way to save the contents of the Q&A? The whole thing will be recorded, yeah. So feel free to go back and then skip to the end there and reference the answered questions. That's probably the best way for now.
Yeah, I think we should be able to. I don't know if Peter's on, but there should be a way of being able to save the actual contents of the Q&A section. And if we do, we'll post that file so that you all can sort of read through the questions and answers.
Yes, we can. I just like to confirm that.
So if we do get that confirmed, then what'll end up happening is if you're part of the Data Science for Good group, we'll make sure that that's posted in our reference section. So that'll be available for everybody. All right, well, I think that's it. Do we want to talk about what's going to be happening next?
I think we're good to go.
Yeah.
Yeah, looking forward to seeing people next Saturday for our Tableau workshop. We'll be going through a lot of the visualizations in there, so it'll be a great time.
Absolutely. Look forward to seeing you all next week.